Hi, I'm David. Intake air temperature, or IAT sensors, are essential to help the modern motor vehicle comply to strict emission regulations. They can have different types of faults, resulting in various diagnostic trouble codes. In this module, we'll be looking at P0113 or P0110 symptom byte 07, inlet air temperature sensor, voltage high. The IAT sensor is a passive sensor in which resistance changes with temperature. The electrical resistance decreases as the temperature increases, and vice versa. The varying resistance affects the voltage drop across the sensor terminals and provides electrical signals to the engine control module, or ECM, corresponding to the air temperature. The ECM uses the air temperature information as a correction factor for fuel, spark and mass airflow. The normal voltage drop range for the IAT sensor on this vehicle is 0.2 to 4.6 volts. If the voltage goes above this range, then a P0113 or a P011007 sensor voltage high will set. From the table of faults, it can be seen that the cause of a P0113 is an open circuit, high resistance or short to voltage on the signal or ground wire. This can occur in the signal wire itself, the ground wire, the sensor or the module. When dealing with temperature sensors, there's a tip you can use if you've got a scan tool and the vehicle's been standing overnight or for an extended period of time. With the ignition on and the scan tool plugged in, I'll compare the readings of the coolant temperature sensor and the intake air temperature sensor. They should be within a couple of degrees of each other. This will help decide if one of the sensors is not reading accurately. The intake air temperature is at -40 degrees and the coolant temperature is at 22 degrees Celsius or 72 degrees Fahrenheit. This indicates a problem in the IAT sensor or circuit. If the sensors were measuring close to the same temperature, this would indicate that the module is receiving the correct information. If the readings were like this on a cold engine, then it indicates a fault. A DTC will not usually set under these circumstances because the IAT sensor is still within its voltage limits. The customer, however, may be complaining about poor performance or excess fuel consumption. Referring to the schematic, it can be seen that the IAT sensor is part of the mass airflow sensor. The IAT sensor has a ground connection shared with a mass airflow sensor on one side and is connected to the ECM on the other. There will be a pull-up resistor inside the ECM which will be connected to a 5-volt reference. Some systems can have a dedicated low reference connection back to the ECM, and others can have a low reference supplied by a vehicle ground, as seen here. To start the diagnosis, it's necessary to disconnect the mass airflow sensor. I can now check for the ground connection. The best way to do this is use a multimeter set on voltage. It's a good idea to set the range to 2 decimal places. This will allow the meter to read quicker and prevents any misleading readings in millivolts. You'll need to know the battery voltage, so make this measurement first. Now I'll check the voltage between the connector ground pin and battery positive. Now I should get pretty close to battery voltage. If there is no voltage reading, this would be an open circuit. A very low reading would indicate excess resistance. My reading is within specifications, so I can move to the other IAT connector terminal. With the ignition on, I'll be looking for 5 volts between the connector and battery negative. I have no reading. If the voltage is correct, then the possible causes are an open circuit sensor or a short to voltage on the signal wire. If the voltage is above 5 volts, then it could be a short to voltage or an ECM fault. To test the sensor for an open circuit, use a multimeter set on ohms to check the resistance. An open circuit or very high resistance indicates a fault. To test for a short to voltage, turn off the ignition, unplug the ECM, turn the ignition back on and retest. If the voltage is still there, then the harness wiring is short to voltage. If the voltage is now gone, the signal wire is either short to another wire going to the ECM, or there's an internal fault in the ECM. One way to check the harness is to connect one probe of the multimeter to the signal wire at the sensor and see if you have a connection to any pin other than the signal wire pin at the ECM. If you have access to a circuit tracer, then it will be much easier. Simply connect the tone generator to the signal wire and see if the probe can pick up the tone on any other wire. If either of these methods doesn't produce a result, then the fault must be in the module. That's the diagnosis of an intake air temperature sensor, high voltage. As you can see, it's not a difficult process, providing you follow a systematic approach. Always deal with one part of the circuit at a time. Diagnose, don't guess. And always remember, training is the key to your success. Bye for now.